Yeah. So, whoa. This is unit 1, which is right triangle trig and trig on the unit circle. This is our review. So the first section is asking you to draw a picture, okay, and then find alpha, the reference angle. Okay, some people I know asked questions in class. They're like, what is alpha? Alpha is just a variable. They're just saying use alpha to label the reference angle. So the point of these 4 is to be able to find your angle. Like, do you know where the angle is? I'm going to go ahead and draw a little XY axis for each of these so I can sketch them. Okay, and then know how to find the reference angle. What is a reference angle? Yeah, it's how far is the terminal side of the angle from the x-axis. Okay, and it's from the negative or positive side of the x-axis, whichever it's closer to, because we know that a reference angle is, what do we know about all reference angles? They're always positive, and there was something else we learned about them. They're always between what and what? They're always what size? Between 0 and 90. If we're in degrees, what is that in radians? Well, 0 is still 0. What's 90 in radians? Pi over 2. Okay, so if you're in degrees, you know that your answer should be between 0 and 90. If you're in radians, you know that your answer should be between 0 and pi halves. And the reason is, what we just said a reference angle is how far from the x-axis the terminal side is. So just think about this. If I'm on the y-axis, that's as far from the x-axis as I can get, right? And what's the angle between them? 9. That's a 90-degree angle between the x and the y. So it's never going to be more than 90 degrees, okay? Because if I go past 90 degrees, now I'm closer to the x-axis over here. It's like an acute angle now, okay? And if you're on the x-axis, it's 0 degrees between them because you're on it. So that's why it's always between 0 and 90, or 0 and pi halves. And it is always positive because it's just talking about the distance between them. And there's no direction for a reference angle. All right, now negative, some of y'all are still struggling with a negative angle. Remember, positive is going counterclockwise in the order the quadrants are numbered. Okay, negative, you go down into quadrant 4 first. You're going clockwise. Okay, but I need to go clockwise 4 pi thirds. Okay, you can look at your unit circle if you're able to read this. Remember, all of these with the denominator of a third are pi thirds, okay? And also the x-axis. So if I'm counting by thirds, I go 1, 2, 3, 4. So 4 pi thirds in the negative direction takes me here to where positive 2 pi thirds is, right? Y'all understand that? So when I go to draw this is in quadrant 2 right here. It is not done being drawn. That's not a complete drawing. What's missing? The arrow showing the direction. That is negative 4 pi thirds. Now the reference angle, which we're going to call alpha, okay, is just how far is that from the x-axis. So here is what I'm looking for, that angle right there. Again, I just counted around in thirds. Remember, I went here. This was negative 1 pi third, negative 2 pi thirds, and then this was negative 3 pi thirds, right? And then here was 4. So what's the difference from a 3 pi thirds to a 4 pi thirds? What is the size of that angle? Does anybody remember when we were learning about reference angles and I talked about in radians? You can see the reference angle in the angle, pi thirds. As long as that fraction is reduced, that right there is the reference angle. There's 1 pi thirds between those two. 3 pi thirds to 4 pi thirds is a difference of 1 pi third. You all okay with that? Okay, 11 pi 6. Hopefully, you can use your unit circle. You can say, oh, 11 pi 6. That's right here in quadrant 4. Okay, so if I need to draw that, here's my initial side. I go around almost all the way, 11 pi 6. A full circle would be 2 pi, which would be 12 pi 6. So how short am I from a full circle? What is the size of that reference angle? Pi 6, you can see it right there, pi 6. All right, degrees I think is easier for many of you. You work a little better in degrees. This one is negative though. So we're going negative direction 60 degrees. I don't know why that's not going from the origin. Okay, so the sketch, the arrow would look like this. Now the reference angle, how big is that angle? It is 60 degrees. If your angle is acute or a negative acute, the reference angle is the same size as the angle itself. Okay? It's not negative though, because the reference is always positive. All right, last but not least, this is more than one revolution, one turn around the circle, right? What's one lap around the circle? What would another lap be? 720. So how much past 720 am I going? Okay. So that would put me here. Okay, so now when you sketch this, your arrow is going to spiral around a couple of times and then do that extra 150, right? Okay, so we did 360, 720, and then 870 was 150 more. So it's coterminal with a 150 degree angle, isn't it? Okay, so there's the sketch of it. Now the reference angle is here. How far from the x-axis is that terminal side? Well, y'all just told me this was an extra 150. So 150 to 180, that's a 30 degree angle. Y'all okay with that first part? Okay, so you have to know where the terminal side is based on the angle given, radians and degrees, positive and negative, and you have to be able to find reference angles. Good? Okay. So the second section wants us to find all 6 trig functions. Okay. So the first thing I'm going to do, if it's an ordered pair, if you are given an ordered pair and you're told to find the trig values for an angle whose terminal side goes through this point, you need to plot the point and sketch the triangle to that point. The hypotenuse comes from the origin to that point. Where's 3, 3? What quadrant? Okay, so positive, positive, right 3, up 3. So then I create a right triangle with the vertical, which is the y value, and the horizontal, which is the x value. So I went over 3, up 3 to get to this point, 3, 3. Does that make sense? Now, this is actually a special case. Does anybody recognize what type of right triangle this is? It's isosceles. The legs are equal, aren't they? What do we know about the angles of an isosceles? They're what? If the legs are equal, the angles are equal, right? The base angles. So if they're the same, what do they have to be? Well, this angle's 90. So together, these two have to be 90 because a triangle's 180. So what's 90 split into two equal parts? So it's a 45, 45, 90 triangle. Because I know that, I can now use my unit circle. Because 45 degrees is one of the special angles that we learned on the unit circle, right? So I could come over here to my unit circle. I could say at 45 degrees, here's cosine, sine, tangent, right? Cosine is the x, sine is the y on the unit circle. So because I know it's 45 degrees, since it's isosceles, I can do this a little quicker than the other problems that give you an ordered pair. Because I know that tangent at 45 degrees is 1, sine and cosine are both √2/2. And then for the reciprocal functions, sine's reciprocal is cosecant, cosine's reciprocal is secant, and tangent's reciprocal is cotangent. What's the reciprocal of 1? Not the opposite. We're not changing signs. Reciprocal just means flip the fraction. So it's just 1. Remember when we were doing the activity, I gave you that list, that little reciprocal review. If you flip 1/1, it's still 1. We said the reciprocal of 0 was undefined. We said the reciprocal of square root of 3/2 was 2√3/3 once we solved and rationalized. We said the reciprocal of 1/2 is what? Just 2. And the reciprocal of √2/2 and √3/3, those both followed the same rule. What are their reciprocals? Because if I were to flip this, remember we said if I flip this, it becomes 2/√2, and then I have to rationalize. And then those 2's reduce, so it's just √2. So if you can just remember that relationship for reciprocals, it saves you from doing that work every time. The same thing applied here. Okay, so these were the list of reciprocals we went over when we were doing that activity last week. So if you can remember those, that's going to help you work a little quicker, make things a little easier. So the reciprocal of 1 was 1. The reciprocal of √2/2 is just √2. So both of these, secant and cosecant, are just √2. Everything's positive. Should everything be positive in quadrant 1? Yeah. All students take calculus. All students take calculus. All the trig functions are positive here. Now, if you didn't make the quick recognition that that's an isosceles triangle and therefore a 45-degree angle, it's okay. That's not how you had to answer this. It was just quicker. You could have done Pythagorean Theorem to find this missing side and then set up all of your ratios and reduced them. That would work as well. That's what we're going to do in number 6. We'll go through that process in 6. Because this one, x and y are not equal. This is not isosceles. What quadrant is that point going to be in? Yeah, we're going right and down. So this is quadrant 4. So I'm going to sketch my triangle in quadrant 4. I'm going over 8, down 2. Okay. So to get to that point, I go over 8, then down 2. That's the point, 8, -2. Now, we've talked about our trig ratios in terms of x, y, and r, and also OA and H. Okay, as an ordered pair, this is x, this is y, and this would be r. This, if this were a point on a circle centered at the origin, this would be the radius of the circle. That's what r is representing. If you're still struggling with the terms or the ratios in terms of x, y, and r, it's okay to use OA and H. If that's easier for you, it's always from the central angle here at the origin. This is opposite, this is adjacent, and this is hypotenuse. If you like that better, that's fine. You're going to get the same answer as long as you label them correctly. Now, we are missing one of the 3 sides of the triangle, so we do have to do Pythagorean theorem. So the legs are what we know. So that's a squared and b squared. And I know I've said this, I'll say it again. Don't worry about a negative when we're doing Pythagorean theorem, because when we square it, it's going to come out positive anyway, right? Okay, so 2 squared and -2 squared, that's 4 no matter what. So when you're doing the Pythagorean theorem, it's okay to not put the negative. So this comes out to 64 plus 4, so that's 68. And then you have to take the square root to get rid of the square. So the square root of 68 is that r. Now, if your radical can be reduced, you need to reduce it. And we've been practicing this. Factor tree. Tell me any factors of 68. We know it's 2 because it's even, so it's divisible by 2. 2 and what? Okay, 2's prime. 34 I can break down. Definitely 2 again, still an even number, right? 17. Now, can 17 break down or is it prime? That one's prime. That means it can only be multiplied by 1 in itself. Or you can only multiply 1 in itself to get the number. Okay, so when you have your factor tree, remember you are looking for pairs of numbers. So there's a pair of 2's. Remember, 2 has a friend to play with, so he gets to come outside the radical. 17 does not have a partner to play with, so he stays inside. Okay, so that's the reduced or the simplified radical. So 2 root 17 is that third side of the triangle. Yes, but none of your answer choices are going to look like that. They're all going to be reduced. So you need to be able to know what's equivalent, because you're not going to see that as an answer choice. You're going to see the simplified radical. All right, so now I'm ready to give the trig functions. I know all 3 sides, so I can give my ratios. If you need to jot them down again, you can. Sine is y over r, cosine is x over r, tangent is y over x, or if you're the one thinking of OA and H, O over H, A over H, O over A. I don't care which ratio you think of as long as it's correct. One of those 2 for each of these. So sine would be -2 over 2 root 17. That is not a rational or simplified answer, is it? Rational means there's no radical in the denominator. Okay, this is not rational, it's irrational. Okay, and this can be reduced. What can you reduce here? The 2 over 2? That's just a -1 in the numerator, right? 2 divided by 2 is just 1. Okay, but now I have to rationalize by multiplying by the radical that I want out of the denominator. So root 17 times root 17. The whole point of that is just to get the 17, get rid of the radical. And in the numerator, that's still negative root 17. So that's sine. Cosine is a over h, so 8 over 2 root 17. We can simplify and rationalize here as well. What simplifies? What's 8 over 2? That's a 4. Then I'd go through the rationalizing. If you get rationalizing, you can do this part in your head. You do not have to show that every single time. Some of you are good with it. I'm still showing it just to make sure for those who still aren't quite confident with it. So there's cosine. Tangent is y over x. So negative 2 over 8. I can reduce that. What does that reduce to? 1 over 4. Now it's negative 1 over 4. Now let's just double check something real fast. All students take calculus. So what's supposed to be positive in this quadrant? Cosine. Is it positive? Are the other two negative? Good, that checks out. So then the reciprocals, I flip the fraction. Cotangent's going to be the easiest. What's the reciprocal of negative 1/4? Just negative 4. Keep the sign. It was negative, so this is negative. Okay, here, when you have done the rationalizing process, don't flip this final answer because then you have to re-rationalize. Remember, go back to how it was here and flip it. So 4 over root 17 is going to be root 17 over 4. Okay, negative 1 over root 17, flip, this will just be negative root 17. Okay, that was a lengthy one because you had to reduce the radical and then you had to simplify and rationalize multiple of your ratios. They're not all going to be that hard. And I'm telling you right now, a question on the test is not going to ask for all 6. It's going to ask for one of them. But I need you to be able to find all 6 because you don't know which one is going to be asked, right? Okay with that? Okay, now 7, we're doing the same process, but instead of being given an ordered pair to plot, we are told what quadrant we're in, and we're told one of the 6 ratios, okay? So this is similar. We need to draw our triangle. They tell us it's in quadrant 3. Now what's different is I don't just immediately know the x and y because they didn't tell me the ordered pair. So I just know I'm sketching a triangle in this quadrant. I need to know my ratios. So we said, I'll go ahead and write the 6 out so we can review the ratios. And then the reciprocals. Now one of them's given, cosecant, negative 2. Boom. Got one of the 6, right? What's the reciprocal of negative 2? Nope. Yeah, this one doesn't have a radical, so the reciprocal is not going to have a radical either. Just negative 1/2, because right now this is understood to be over 1. If you need to see it that way to flip it, that's negative 1/2. So, oh, we've already got 2 of them. Okay, now the ratios. Sine is y over r. Or you may prefer to think of it as O over H. I don't care which way you think of it, but when I label this, this is the X movement, the horizontal, this is the Y movement, the vertical, this is R. Or if you prefer the OA and H, remember it's from the central angle here, this is opposite, this is adjacent, and this is hypotenuse. So whichever way you're thinking of it, we know this side right here, the O or the Y, is 1. Agreed? Okay, so this is a 1. And we know that the H or the R is a 2. Now, which one of those is the negative coming from? Where's that which one does the negative go on? I've heard both answers. What'd you say, Andre? Not both, because if it was a negative divided by a negative, it would come out to a positive, right? What quadrant are you in? You're in quadrant 3. So what's negative in quadrant 3? What? Well, not tangent. Sine and cosine are negative, but both ordered pair, both pieces of the coordinate, right? The x and the y. The y is negative because you go down to get to this point, right? You're going left and down. Those are both, the x and the y are both going to be negative. So that's where that negative's coming from. R is never negative. Your hypotenuse is never negative. It's the x or the y, the O or the A that has the negative on it. Okay? So now it's the same as the last one. I know two sides of a right triangle. How do I find the third? Pythagorean theorem. Okay? So x squared plus y squared equals r squared, a squared plus b squared equals c squared, however you want to think of that. Okay? I said don't worry about the negatives, right? In Pythagorean theorem. Okay, and that's 2 squared. It does matter that 2 is the hypotenuse. It's the c in Pythagorean theorem. Okay, the legs, the hypotenuse. So when I go to solve for the missing side, that's 1. 1 squared is just 1. 2 squared is 4. I have to subtract the 1 over. So 4 minus 1 is 3. And then how do I get rid of the square? Square root. Square root of 3 cannot be simplified. 3 is prime, right? No factor, so it's just square root of 3. But it's negative because we're in quadrant 3. X is negative. Y'all okay with that? So now we're ready to give our ratios, now that we have all 3 sides. So we've got sine and cosecant already. Okay, cosine is x over r, tangent is y over x. Okay, or a over h if this is how you're preferring it, and o over a. All right, so x over r. No rationalizing, simplifying needed. I did review the reciprocal of this with you a couple problems ago. What's the reciprocal of that one? Yeah. Okay, tangent is y over x, so that is -1 over negative square root of 3. Negative divided by negative, this is going to be positive. And when I rationalize this, root 3 over 3. What's the reciprocal of root 3 over 3? Just root 3. Tangent came out positive. Is tangent supposed to be positive in quadrant 3? Yes, and the others are all negative. So far, so good? Okay. All right, the next section is using the unit circle. This is find this angle and then determine the trig function. This is what we were doing in that activity where I had you roll the dice to pick a trig function and spin the spinner to pick an angle. And then you had to go solve it using the unit circle. That's these types of questions. Okay, so I'm going to pull up the unit circle for each of these. So tangent of 7 pi thirds. Is 7 pi thirds on this unit circle? We don't see it written because it's more than a circle, right? 2 pi, if we're thinking in thirds, that would be 6 pi thirds, right? So 7 pi thirds is 1 more pi third, right? So it's here, it's coterminal with pi thirds. So if you need to sketch it so you can see It's going past a full circle. It's to here, okay? But it's at the same place as pi thirds. Remember, if you can find the reference angle, you can answer any of these questions, okay? So the reference angle is pi thirds. Okay, so at pi thirds, what is tangent? At pi thirds, what is tangent? Square root of 3. That's your answer. Okay, 24 pi 6. You can go around by pi 6 and try to find that. Or if this is not reduced, just reduce this. What is 24 divided by 6? 4. So this is 4 pi. Where is 4 pi? Where does that put you? 2 full circles, right? So that's at this point, 1, 0. They're asking for cotangent. So tangent here is 0. Cotangent's the reciprocal. What did we say the reciprocal of 0 is? Undefined. Okay, cosecant at 120. 120 is on the unit circle. Let's find it. 120 is here in quadrant 2. Here's my ordered pair. Cosecant is the reciprocal of sine. Sine on the unit circle is what part of the ordered pair? Y. So y is root 3 over 2. What's the reciprocal? 2 root 3 over 3. Are you following the process? Okay, what I did was I said sine was root 3 over 2, and then I got the reciprocal for cosecant. Okay, secant at 135. 135, here we are. Secant is the reciprocal of cosine. Good. Cosine is the x or the y? The x. Okay, so it's negative. Cosine is negative here. You can write that down if you need to. Cosine at 135 is negative root 2 over 2. So what's the reciprocal of that? Just negative root 2. Okay. -12, negative pi 6. So again, in the negative direction, 1 pi 6, that's going to put me here at 11 pi 6, right? Okay, so I'm here at this point at 11 pi 6, and I want to know cosine. Cosine is the x, so it's positive root 3 over 2. Because cosine is positive in quadrant 4. All students take calculus. The C is for this is what's positive. All of them are positive. Sine, tangent, cosine. Cosine is positive in quadrant 4, and you can see on the unit circle that value is positive. The y is the negative. Like as an ordered pair to get in quadrant 4, you're going right and down. Right is a positive movement, so x is positive. All right, 18 pi fourths. Reduce it if you can. What is 18 fourths reduced to? 9 halves. Okay, so 9 pi halves. If I count around in halves, 90 degrees is a half pi, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pi halves is the same place as pi halves, right? Y'all agree with that? Okay, so at this point on the unit circle, what is sine? Sine is the y, so it's 1. If you need to sketch it to show, that's where 9 pi halves was. We did 4, 5, 6, 7, 8, 9. That got us here. At that ordered pair, that is sine. That's where 1 is coming from. Be boxing these in so y'all can see what the final answer is. Everybody still with me for this type of question? Using the unit circle. Tangent at 225 degrees. 225, that's on the unit circle. Tangent, what is it? Tangent is y divided by x, but we've already actually calculated it. It's 1, because anything divided by itself is 1, and x and y are the same there. And tangent's positive here, right? Because a negative divided by a negative comes out positive. So your answer is 1. Now I have a nice little surprise for you. I'm going to give you this completed unit circle for the test tomorrow. You do not have to fill it in, but you have to know how to use it. Okay? So I will give it to you filled in. You have to know how to use it. You have to find the angles. You have to know x is cosine. You have to know y is sine. You have to know the reciprocals. Everybody okay with that? Okay. All right, 15. Find the coordinates of the point of the intersection at 210 and an angle on the unit circle. So this is just saying at 210, what are the coordinates? That's it. Again, that's being able to read and use your unit circle to understand what they're asking. So it's negative root 3 over 2, negative 1/2. That is cosine. That is sine. 16, what quadrant would you be in if cotangent is less than 0, that means negative, and cosine is greater than 0, that means positive. So remember, all students take calculus. Cosine is positive in 1, because they're all positive, and 4. Cotangent is negative, the same place tangent is negative, right? Tangent is positive here, so it's negative here and here. So where's the overlap? Quadrant 4. Okay, if it is an acute angle, where is it? What quadrant? 1, between 0 and 90, that's quadrant 1. So we know we have triangle in quadrant 1. Secant is the reciprocal of cosine. Cosine is what over what? X over R or A over H, depending on which you prefer. So this is the reciprocal. So you can think of this as R over X or H over A, however you want to, whichever letters you prefer. Okay, so they're telling us the hypotenuse, or R, is square root of 41, and the adjacent side, or the X, is 5. How can I find the third side? Pythagorean Theorem. What happens when you square square root? Yeah, that's just a 41. Okay, so then we're solving. So we subtract the 25 over and get 16. What's the square root of 16? So that missing side is 4. So now they want tangent. Tangent is y over x or O over h, depending on how you label. So what is it? 4 over 5. Okay. Y, that's x, that's r, or O, A, and H. Y'all okay with that one? Okay, I'm gonna try and squeeze in 18. I know the bell's gonna ring, but somebody in here had asked about 18, so I wanna make sure and answer it. Questions we didn't get to, the video will be posted, okay? 18, oh, this is actually a quick one. When you see inverse trig, whether it's inverse sine, inverse cosine, or inverse tangent, inverse is how we find a missing angle, right? So this is asking at what angle is sine tell you -1. So it's asking, where on the unit circle is sine -1? Sine is the y, right? So I look for where is y -1, and it's right here. So my answer is 270 if it's in degrees, or 3 pi halves if it's in radians. So that's at 270 or 3 pi halves. Does that make sense? Inverse trig means what's the angle? That's looking for the missing angle. All right, I'm going to stop this recording. The next recording will pick up with 19.